Okay, this is my submission for Chapter 15, video assignment number 1. So here we have a few different parts of the actual problem itself. Basically we have a solution that is 0.001 molar chloride and 0.01 molar in oxalate. So like it says in the problem, we need to remove the chloride and keep the oxalate. And you decided to use selective precipitation. We're given solubility products for silver chloride and also for silver oxalate, which we'll use in this problem. And okay, perfect. So part A, we need to calculate. There we go. We need to calculate the concentration of silver ions where silver 1 chloride starts to precipitate. And the way that we do that is we're going to use our KSP value for silver chloride. And then we're going to plug that into our KSP equation here. And then we are going to plug everything in except for our silver concentration to find that concentration. So a precipitate will form at this molarity of silver. Now the second part of this problem, we need to calculate the concentration of silver 1 ions where silver 1 oxalate precipitates. So here we're going to use the KSP value for our silver oxalate all the way down here. And then we are going to solve for, like I said, this value right here. It's important to note that this value is going to be squared. If we don't square this, then we're going to get a totally different value. And that is, just very crucial. So we end up with this value, 2.324 times 10 to the negative 5th molar. This is the concentration of silver 1 ions where silver 1 oxalate precipitates. Now on to part 3. It says once you raise the concentration of silver up to the concentration where silver 1 oxalate starts precipitating, what is the remaining concentration of chloride? So we plug in our initial KSP and we plug in everything except for our concentration of chloride, and this is the value that we get. Now for the very last part, we are going to use the percent change equation, finding what percent of chloride is removed this way. So we use our initial concentration of chloride and our final concentration of chloride, and we divide it by the initial. So final minus initial over initial times 100. And this is the percentage that is removed. Obviously you can't have a negative percentage removed, so you just change it to positive. And that is my submission.